Physical principles of sensing. Myself, I am Kishore Borakade, Assistant Professor, Mechanical Engineering Department from St. Vincent Pallotti, College of Engineering and Technology, Nagpur. Sensor is a device that receives a stimulus and responds with an electrical signal. So we can measure different quantities with the help of sensors. For example, motion, position, displacement, velocity and acceleration. We can measure force, strain, pressure, flow of a fluid, sound, moisture, light intensity, radiation, temperature, and chemical presence. So the response from the sensor is electrical signal. So when we say electrical, we mean a signal which can be channelized, amplified, and modified by any electronic devices. So any sensor is an energy converter. So it converts any form of one energy into another energy. This conversion can be direct or it may require transducers. For example, a chemical sensors may have a part which converts the energy of a chemical reaction into the heat, and another part, a thermopile, which converts heat into an electrical signal. So in this particular sensor, there might be a different kind of properties we can use: charge, fields or potential differences, capacitance, magnetism, induction, resistance, piezoelectric effect, Seebeck and Pelter effect, thermal properties of a material, heat transfer or light. This kind of properties can be used in a sensors to measure any particular physical quantity. Sensors may be of a direct type or indirect type. So in direct type, there is a conversion from particular physical quantity into an electrical signal. Thermocouple is an example where the temperature is converted into the equivalent voltage. In indirect sensor, a temperature, for example, can be converted into steps and transformed to a measured signal into an electrical signal. A fiber optic displacement sensor is an example of indirect type of sensor. So the property of capacitance is also used in a sensor. So this capacitance means when the two isolated conductive objects of any shape which can hold an electric charge is called a capacitor. And this property of capacitance can be used in displacement sensor. If the inner conductor can be moved in and out, the measured capacitance will be a function of length L. In water level sensor, the total capacitance of a coaxial sensor shown in the figure, where the capacitance of the water free portion plus the capacitance of the water filled portion. As the level of water changes, the total capacitance changes. In sensors, a magnetic field property can be also used to measure any physical quantity. When the electric current flows, it develops a circular magnetic field around a conductor, and this property can be used in any sensor. Induction property. A phenomena related to a magnetism is induction, and the generation of voltage from a changing magnetic field can also be used in any particular sensor, induction sensor, to measure any physical quantity. We can also use resistance as if it's a particular property in a sensor to measure any physical parameter. Moisture. In any agriculture application, to measure a moisture is very important, and for the hygrostor, the resistance of the polymer changes with the absorption of water molecules. So the change in resistance will be directly related to the moisture content in the soil. Piezoelectric effect is a very famous application in many sensors, and when a stress is applied on a crystalline material, then electric charge is produced. In the piezoelectric sensor, the piezoelectric coefficient in the x direction and the force in the x direction can be equivalent to the stress applied. Seebeck and Peltier effects are also used in a sensor to measure any physical quantity. The Seebeck effect is directly proportional to the thermal energy, and the resultant in is the electrical signal. In light, electromagnetic radiation property is important to measure any physical parameter. So we can conclude a sensor is a device that receives a stimulus and responds with an electrical signal. The final stage of any sensor is dependent upon electrical properties of the sensor material. The material introduced today are used in the design and fabrication of many different types of sensors. So, using different material and different properties, we can measure different physical quantity with the help of sensor.